Hello again. For this report, I'm at the Louwman Museum in The Hague. Normally you visit here to see a fantastic collection of antique cars, but this week I came to discuss the future of quantum optical communications with many Optica members presenting at the Inside Quantum Technology Conference. Let me share some takeaways. One of the main challenges of quantum optical communications today is the practical distribution of useful entanglement over long distances. That's between cities, countries, continents, and even into space. Quantum is needed to achieve the most secure communication system in history. But quantum communication is done with a very low photon count. So how do we protect the photons against losses over a long optical fiber? In classic communication, we use optical amplifiers, but things are not so easy in the quantum world. It is impossible to amplify a single photon, but the community has been working very hard on this. While entangled photons typically come from the same source, one of the biggest discoveries of this century is that quantum photons can be entangled even if they have never interacted with each other. But so-called quantum swapping requires an almost impossible level of synchronization in the network. The quantum memory commercialized by our corporate member QNect beautifully solves this issue. Their CEO, Noel Goddard, explains this better than I.
The synchronization issue is solved by introducing quantum memories. These memories hold one photon from each pair, while the other photon travels to a swapping station. Upon a successful swap, the memory will release the stored photon for the next swapping step. With memories, if one block of the chain fails to swap, we only need to repeat that block.
You will soon see this in action. On 14th of April, our World Photonics Tour will take me to New York to witness the new Gotham Q testbed, connecting New York University to the Brooklyn Navy Yard. QNect is poised to unlock quantum internet capabilities for customers in financial services, critical infrastructure, and telecom in the New York metropolitan area. But back to The Hague. Beyond the discussion of quantum memories, other challenges were raised at the IQT conference. How do we provide scalable, integratable, and multiplexable quantum entanglement sources, such as the one from Haag, Qubitech, Thor Labs, or Quantum Optics Jena, among many others? I can't mention you all, feel free to comment below. It's clear to me that the success of quantum technologies is closely linked to what's needed next in photonic integrated circuit development. I hope quantum companies will get more involved in defining the roadmaps for photonic integrated circuits. For example, getting involved in the next IPSR international roadmap, in which Optica is heavily involved. As my friend Martin Haag says, if all this keeps you up at night, join the global effort to get it done. Onward!